Hi everyone, this is Liam Grace Gamay, student 20 from CE 443 Hydrology class. For today's video, we're going to tackle about the groundwater exploration and exploitation in the Philippines. First is, let us know what is groundwater. Groundwater is an invisible natural resource. It is available in different proportions, in various rock types, and at various depths on the surface layer of the Earth. About 1.7 of all Earth's water and 30.1% of fresh water on the Earth occurs as a groundwater. It is more desirable than surface water because of the following reasons. First, it is commonly free of pathogenic organisms and need no elaborate purification for domestic and industrial uses. Second, temperature is nearly constant, which is great advantage if the water is used for heat exchange. Third, turbidity and color are generally constant. Fourth, chemical water storage is always greater than the surface water storage so that the ground water supplies are not seriously affected by short duration of drought. And lastly, biological contamination in groundwater is seldom noticed. It is said that more than 60% of global population thrive by using only the groundwater resources. The groundwater which was existing at the shallow depths in the open wells has gone deep due to the overexploitation. Thus, exploring these water sources become a challenge task to geoscientists. So, let us find the objective of groundwater exploration. Groundwater exploration is objective is to study and understand the hydrological cycle of the region, to have an overall concept about the type, the nature, and the number of aquifers, then the quality of groundwater. Usually, groundwater exploration project passes through the phase of regional surveys, detailed surveys, and exploration of groundwater by means of boreholes and wells. Next, there are four methods and techniques used for groundwater exploration. First is the aerial methods, and then we have the surface methods, the subsurface methods, and the esoteric methods. So let's tackle first the aerial methods. Aerial methods is the most common convenient methods for recognized sun surveys of large areas aimed at identification of watershed characteristic of basins and locating prospective areas are the methods of area explorations. So we have remote sensing as one of the aerial methods that is very common. It refers to obtaining reliable information about Earth's surface without physical contact through the use of electromagnetic radiation or EMR as source energy and the sensor to record the images. The aerial photos are those taken from an aircraft mounted with the cameras which shoot directly the terrain within the visible spectrum or in the near infrared region. The photos are taken in the panchromatic or black and white color and infrared. The RS data or the remote sensing data are found extremely useful in identifying the virus geomorphic units, structures like fault, linements, joints, fractures, folds, and drainage, which are important since they control the movement and occurrence of groundwater. RS provides multispectral, multitemporal, and multisensor data of the Earth's surface, which are suitable for mineral explorations, water resource evaluation, environmental monitoring, and groundwater targeting. So let's elaborate aerial photography pa. In aerial photography, groundwater investigation of an area requires the nature of the lithological units, their structural disposition, geomorphic setup, surface water conditions, and climate of the area, which can be studied through the satellite images and aerial photographs that provide detailed information about large part of the surface of the Earth in a very short time. Remote sensing data do not directly detect deeper subsurface resources, but RS techniques have been effectively used in groundwater explorations. The second method or the techniques used in groundwater exploration is the surface methods. These methods are easy to operate and implement. This requires facilities like topo sheets, maps, reports, some field measurements, and interpretation of data in the laboratories. The most common and time-tested methods are the surface variants of different techniques from geology, geomorphology, hydrogeology, geophysics, and etc. These methods are applied where the purpose is the detailed study of the distribution of potential water-bearing zone in the lateral and vertical directions. So first, let's tackle the geological methods. The groundwater occurrence and movements mainly depend on the geology of the area. The geological studies are very much essential. The type of terrain, rock formations, lithological units, geological structures like alignment, faults, joints, and fracture system have to be studied in depth. So, and only after the geological investigations, the type of physical methods to be conducted may be decided. A geologic investigations begin with the collections, analysis, and hydrogeologic interpretation of existing topographic maps, aerial photographs, geologic maps, and logs, and other pertinent records. This should be supplemented when possible by geologic field reconnaissance and by evaluation of available hydrologic data on stream flow and springs well yields, groundwater recharge, discharge, and level and water quality. In some places, the drainage may be fully controlled by the presence of the minor and major structures like the joints and the faults and the lineaments. Next, geomorphological methods. After a thorough study of the satellite imagery and geomorphology map, a field check is highly necessary to know the geomorphological features to assess the groundwater potential. These units like the pediments, the flood plains, the drainage patterns, soil types, lineaments, which primarily control the occurrence, movement, and potential of groundwater have to be investigated in detail. The third is the hydrogeological methods. The groundwater potential of an area mainly depends upon the hydrological setup, for which a detailed and systematic hydrological survey is prerequisite. A well inventory study is a very important in any groundwater exploration program. So the water level measurements, the water level fluctuation studies are the important factors in the assessment of the groundwater potential. Only by a systematic hydrological study, the groundwater abstracting structures like the open well, the bore well, the tube well have to be finalized. The recharge and the discharge areas ought to be identified. The fluvial hydrological studies like the river and the stream flows, whether it is perennial or etc., details are important in the quantifying the potential. And lastly, we have the geophysical methods for the surface methods. Electrical and geophysical methods comprise of a measurements of signals from natural or induced phenomena of physical properties of subsurface formation. Geophysical methods used in groundwater explorations are the following. Following methods are under the geophysical methods, which is under the surface methods. So the first one is the electrical method. Electrical methods of prospecting include a large group of geophysical techniques employed for investigating the electrical fields of the Earth. Such fields are generated in the Earth naturally or artificially by generators or batteries. Electrical parameters vary depending upon the lithology or more influenced by the presence, content, and the quality of water. So the different electrical properties that influence these electrical fields are primarily the resistivity, the dielectric permeability, and the magnetic permeability. Electrical parameters vary depending upon the lithology or more influenced by the presence, content, and the quality of water. So next is the electromagnetic method. So Electromagnetic methods based on the measurements of conductivity of subsurface minerals or the formation. It is useful for exploring minerals and groundwater. The flow of electrical current in the conductor is always accompanied with the presence of magnetic fields. So the interaction of electrical and the magnetic fields is governed by the Maxwell equation and well-known laws of the Ampere and the Faraday. Next one is the seismic methods. This method is developed from seismology, the science of earthquake, also called applied exploration seismology. It has its basics in utilizing the propagational time of elastic waves excited at the surface. The energy generated at the source travel as waves, and those electric waves have different transmission times. Lastly, for the second to the last is the magnetic methods. So this magnetic method is based on the susceptibility contrast between the anomalous body and the rock around it. Its instruments measuring magnetic susceptibility are called magnetometers, or different types. The flux gate magnetometer, the proton precision, and the rubidium vapor magnetometer. So these are the different instruments used to measure the magnetic susceptibilities. Lastly is the gravity methods. Measurement of the gravitational field at a series of different locations over an area of interest. The objective in this exploration work is to associate variations with differences in distributing of densities and rock types. So based on the measurement of the density contrast between the anomaly causing the body and the surrounding rocks. These methods may be used not just for groundwater exploration but can be also used for the exploration of the minerals, oils, and gas. So that's all for the surface method. Now let's proceed to subsurface methods. The subsurface methods of groundwater exploration includes both test drillings and borehole geophysical logging techniques. So these are done for the government level projects where large-scale investigations are carried out to ascertain the result of the surface surveys. And these subsurface methods, are very accurate as to help in direct observation of the features in the form of the borehole litholongs as core samples and also geophysical measurements of formation properties. And the quantitative data on the aquifers is obtained to determine the suitability of aquifers for exploitations. So now we have the third method. This is the esoteric method. So even from the early ages, groundwater perspective was carried out by water diviners, dowsers, by following certain traditions and belief. So water divining and dowsing methods are still in practice using the Y-shaped twigs, copper rods, keychains, and wristwatch. These attempts were not always successful as they were not based upon the sound scientific reasoning. So that's all for the methods and techniques in groundwater exploration. So now let's proceed to geographic information system. So what is geographic information system, or GIS? It is a computer-based information system used to digitally represent and analyze the geographic features present on the Earth's surface and can be used for scientific investigations, resource management, and development planning. GIS is also capable of capturing, storing, analyzing, and displaying geographically referenced information, that is data identified according to the location. So the following are the components of the GIS. We have the hardware, the software, data, methods, and people. So first, hardware. GIS relies on the computer for storage and the processing data, of course. And then we have the software. This is the core of the GIS system. Lies the GIS software itself, providing functionality to the store, manage links, queries, and analyze geographic data. Next, we have data. So data for the GIS comes in two forms. We have the geographic or the spatial data and attribute or, or attribute. Then we have the methods. GIS systems are designed and developed to aid the data management and decision processes. Lastly, we have the people. The people is the system user, those who will use the GIS to solve the spatial problems. So what is the application of GIS in groundwater exploration? The parameters such as geology, landform, soil, slope, alignment, weather zone, which controls the groundwater occurrence and movement, can be integrated through the geographical information system for locating groundwater potential zone. So GIS has been found to be one of the most powerful techniques in assessing the suitability analysis, and it is also a good tool to delineate groundwater potential zones by integrating different thematic layers which have different control on the groundwater occurrences. Let's proceed to the groundwater exploitation in the Philippines. So, as we all know, groundwater is replenished or recharged by rain and seepage from rivers, and it contributes 14% of the total water resources potential of the Philippines. In the Philippines. So, and then it is also said that the groundwater is used for drinking by 50% of the people in the country. And based on the water rights granted by the National Water Resource Board, or NWRB, since 2002, 49% of the 49% of the groundwater is consumed by the domestic sector, and the remaining percent are shared by the agriculture, 32%, and then the 15% for the industry, and the other 4% is for the other sectors. And it is said that about 60% of the groundwater extraction is without water right permits, resulting in indiscriminate withdrawal and a high percentage of pipe water supply system uses groundwater as a source. So there is a overexploitation of groundwater happening in the Philippines. Like we have 60% of groundwater extraction now. Walang water right permits or walang right permits, thus resulting in the indiscriminate withdrawal of the groundwater. In addition to that, we all know that the quality of the water we drink has a direct link on what happens underground. Like the taste of the water becomes salty because of the seawater intrusion in our aquifers. And this happens when we overexploit our groundwater resources because they don't have enough time to recharge or replenish. And with hundreds of people, with the hundreds of Filipinos using groundwater, or let's say in Manila alone, in Metro Manila alone, indiscriminately extracting water from the deep wells, our aquifer is in danger of not only the saline intrusions but also of drying up because they don't have enough time to replenish, to recharge. And because of that, according to National Water Resource Board Executive Director Ramon Elecala, he said that there is already a saltwater intrusion happening in Manila. There is already saltwater intrusion in the western part of Metro Manila because of over-extraction and the lack of recharging of the aquifers. This happens when we overexploit our groundwater. Kasi nga, just like I said earlier, they don't have our aquifers, they don't have enough time to replenish and recharge. And adding to that non-replenishments of aquifers is causing land subsidence or land sinking that can bring about flooding in the long term. Kasi so not just hindi lang ang pag-dried up or the saltwater intrusions ang tawag dito Hindi lang yun yung consequences pag hindi nakapag-replenish or na-recharge ulit ang ating mga aquifers, but also it can cause land subsidence or pagbaba ng land sinking that can bring about flooding in the long term. And with all of that groundwater exploration and exploitations, these are the thoughts to reflect on. There are several methods and techniques to explore the groundwater potential. The success of the groundwater explorations depends upon the methodology adopted based on the geology and the field conditions. And exploration in the first stage, followed by the drilling, development, and finally, well completion. So it takes many years to bring back fresh water into the aquifer that has been contaminated by seawater, salt intrusion. All efforts then must be taken to prevent aquifers from drying up or being contaminated. Our aquifers are the only sources of drinking water where we can really rely, or in any cases of drought and other calamities. And over extractions of groundwater or over exploitations is already a threat, is already posing a threat to our aquifers, our natural reservoir of water beneath the ground. So the explored water should be exploited correctly and managed properly. So we all know that water is precious. Water is life. So let us conserve. You know, that's all. Thank you.